Welcome to qnawire.
In the given question, we need to show that if a1 is equal to 2, so we need to define the sequence as per an plus 1 is equal to 1 upon 3 minus an. So here, if n is greater than 1, then it is bounded and decreasing. So here we have to state whether the sequence is convergent or divergent. So now let's simplify our question. So first of all, since it is given that a1 is equal to 2, we can show that an plus 1 is less than or equal to an, and we know that an is less than or equal to 2. So here we will let y, which is equal to an plus 1, and x, which is an. So then our value for an plus 1 will be equal to 1 upon 3 minus an, and therefore y is equal to 1 upon 3 minus x. So y upon x will be equal to 1 upon 3 by x minus 1. And if y minus x is negative, then x is greater than 3, or we can say an is greater than 3. So now we can use this induction to show that an is in between 0 to 2. So here we will put as a1 is less than or equal to 2. So we must have to show that a k plus 1 is less than or equal to 2 is also true. Since we know that a k plus 1 will be equal to 1 upon 3 minus ak, and that is 1 upon 3 minus ak is less than or equal to 2, and therefore 1 upon 3 minus ak is less than equal to 2, and which is equal to, when we simplify this, 3 minus ak will be greater than or equal to 1 upon, and from here we can get ak is less than or equal to 5 by 2 minus ak will be equal to minus 5 by 2. So minus and minus sign will be cancelled, and we will get ak is less than or equal to 5 upon 2, which is also less than or equal to 2. And therefore, to show an is greater than 0, we will put here a1 is greater than 0, and we must know that for that we have a k plus 1, which is greater than 0, and when we put down here value 1 upon 3 minus ak, which is greater than 0, so our value 3 minus ak will be as 1 upon 0, which is equal to infinity. And since the last inequality, we can see here, since the last inequality is obviously true, so we can see here that a k plus 1 is greater than 0 must be true. To show an is in between 0 to greater than, less than or equal to 2. And then from this conclusion, we can say here, if it is true, then we can say the series which we have here will be convergent. The series is convergent, and its limits are between 0 to 2. So our answer for this question is the series is convergent and limits are 0 to 2. So here we have our solution for the given question.